Hello, grade 12, Mr. G here. We're going to make a video on naming alcohols. We have already two previous videos of naming hydrocarbons and one of naming alkynes. So we're going to name now alcohols. Now note, the steps are going to be more or less the same. It's very little changes from compound to compound, but it's not a big issue. Okay, so let's just record the functional group of alcohol. Remember, the functional group of alcohol is a carbon that has bonded to an OH. Okay, that is the functional group for alcohol. So we are looking for this one in a chemical compound. Okay, the general formula will be CnH2n plus 1OH. This is the general formula. You can look for the table of it. It's important to learn that one. So this is the alcohol, the functional group of alcohol, and then we're going to see. I will make another video because there are three different types of alcohols, but we will make that video a little bit later on. Okay, so now we're just going to learn how to name alcohols. So let's start with this example. This example is a little bit tricky. You can see the CH3, a carbon bonded to CH3, and Cl, CH2, COH, CH2, CH3, and the carbon is bonded to CH3. So it's a little bit tricky. I recommend you to try to do it. It's never bad, and anyway, this is the way to do it. Now, remember, alcohols, the name will end in ol. Probably we must write it here. Alcohols, the name will finish in ol. That is important to remember. The name will finish in ol, like methanol, ethanol, etc. Okay? Now, the step one, the first step of all, is to identify the functional group, whatever compound it is. This one we already know. We're working with alcohols, so the functional group is there, and therefore is an alcohol. Saying that, the name will finish in ol. Okay? So that is the first step. Second step is determine the longest continuous carbon chain. Now, this is a very important note. As from alcohols towards alcohol, aldehydes, ketones, and carboxylic acid, there is going to be a small change in these names when the number of carbon. So we are going to add an AN at the end. Meth, so we're going to say methane. S is ethane. Prop is propan. But is butane. Pent is pentane. Hex is hexane. Hept is heptane. And so on with the AN. So that is how are the names of the number of carbon is going to be as from alcohol, aldehydes, ketones, and carboxylic acid. For example, if it's methanol, we say methanol, methanol. All right, so you can see that all of them will finish in AN for the number of carbon. This is the only difference. This is only for alcohol, aldehydes, ketones, carboxylic acid. In previous videos, we saw hydrocarbons. You don't apply that rule, and neither to haloalkanes. Okay, so let's go to this step. This step is to determine the longest continuous carbon chain. So let's see possible options that we have. We can go straight. Remember, the functional group must be part of that. And here we have a 1, 2, 3, 4, 5 carbons. 5 carbons. Let's see another option in which we can look for the carbon chain. And this one will be in this way, where it turns that carbon with the OH turned up, and this one will have 1, 2, 3, 4, 5, 6. So 6 carbon. 6 carbon. This one is a little bit longer. So the first one is already out. This option is out. We have that one with 6 carbon. Let's get another option. Let's see another option here. Here we can say now that, for instance, going from here, there, that is another option of carbon chain, and this one will have 1, 2, 3, 4, and 5 carbon. 5 carbon is also smaller, so we take it out. And the last option we have is starting from top and going down all the way and 10 at the corner. So this one will be like so. That is another option. If we count there, we have 1, 2, 3, 4, 5, and 6 carbons. So we have two ways in which we have 6 carbon. There's one, there's the other option. I think the first one is easier because it's more straight. Okay, so we're going to take the first option, which you have 6 carbon. So those are the options. Therefore, if we have 6 carbon, it's going to be hexane. Remember the AN. So up until here, we have that it's going to be hexane and it's going to be all. Okay, so somehow it's going to be all and hexane. That is what we have up until now. So let me just do this so we know what we have. It's like we're getting the data for the answer. We're going to the next step. Next step said number the carbon starting at the N nearest to the functional group. So here we're going to start numbering the carbon starting at the N nearest to the functional group. This is already what we selected with 6 carbons. Remember, just to go back, we have here that the homology series is alcohol, so it's all, and the number of carbon is 6, so it's hexane. Okay, so what else we're looking now for? Numbering the carbon starting from the N nearest to the functional group. So if we start on the left hand side, we have 1, 2, 3, 4, 5, and 6. If we starting from the left hand side, we have 1, 2, 3, 4, 5, and 6. You can see that from the left hand side, the OH is nearest to the end. So we're going to take the one on top and let's then erase all the other numbers at the bottom. We're going to keep the numbering from top. So now when you do that, you must write down the carbon in which the functional group is, which is going to be in carbon number 3. You can see it there in carbon 3. So we come into the all and we write 3 all. Alright, I hope that is clear. It's not a big problem, it's not difficult. So when you do this, when you number the carbons, remember to write down the number in which the functional group is allocated. Okay, that is for alcohol, and we'll see later for the other homology series. So this is what we have. This is step 3. I hope it's clear. It's not that complicated. Let's go to step 4. Now, step 4, we are going to identify the different substituents, means halogens and alkyl groups, any of them. So let's determine if there is any. Okay, it's the branches. So here we have a chlorine. Remember, we write chloro. So we have a chloro there, and it is in carbon 5. So I'm going to write 5 chloro. Here I have a methyl hidden there in this corner, which is in carbon 3. So here I have a 3 methyl. And here we have another methyl, which is in carbon 5. So it's 5 methyl. Now remember, when you have 2 of the same, as we have in here, we have 1 methyl there and we have another methyl there, we are going to combine the numbers and we are going to write the suffix di. So we actually have, what do we have here? We have, let me use the same colors we used before. We have 5 chloro, we have 3,5 dimethyl. 5 chloro, 3,5 dimethyl. So this is the different substituents we have. So up until here we have that, and we also have all. Remember, it was a 3 all, and we have hexane. So this is all the information we have. We have the substituents, we have the homology series, and we have the number of carbon. So all we have to do is to come down and just write the name. So let's see. Remember, we have a 5 chloro. We have a 3,5 dimethyl. We have hexane, and we have 3 all. So we have to combine all this one in a name. So what is coming first? Substituent alphabetical order. If you go to alphabetical order, you can see that chloro here, C, is before M. The D doesn't count. Only the M for methyl and the C for chloro. So first is chloro. So the name will be 5-chloro. 5-chloro. Now is coming the other substituents. 5-chloro, dash between numbers and letter, 3,5-dimethyl. Now it's coming there. Number of carbon is the base, is hexane, dimethyl hexane together. And then the last part is the homologous series, hexane 3-ol. This is the name of this specific compound. I hope it's clear. It's not that difficult. Follow the steps. Take a couple of more examples following these steps and you should be right. Thank you very much for watching. Good luck, and next video will be naming aldehydes. Thanks a lot.